Focus. Okay, so what we're going to start off with, everybody, okay, is we're going to talk about basically how to do the calculus involving inverse functions today, okay? And I'm going to introduce to you the derivatives of the arcsine, arcsecant, and arctangent, okay? Just those three. Those are the last three functions we need to learn.
Did we learn arccosine?
We did not learn arccosine. We're not going to learn arccosine. There's a reason for that, okay? I'll point out the reason as we do them, okay? But first, let's talk about inverse functions, okay? So, some quick reminders. You're late.
No, you're doing the rest of it. It's done already here.
Dear God, man, where were you?
Thank you.
15 minutes.
Hey, the Browns making the Super Bowl?
Inverse
That's offensive.
functions, okay? Listen up, guys. Hey. Okay? The things to know about inverse functions, okay? So a lot of this is just from pre-cal review, real fast. Then I'm going to do the kind of the calculus part of it. Calculus part of it's super easy, but just so a reminder, inverse functions, okay? The first thing with inverse functions is whatever inverse function is, and basically functions f of x and g of x are inverses when f of g of x equals g of f of x, which is equal to x. So that way when I put the two functions together, I get x back out, okay? Now, we've seen that before. We also know other things like they have to be one-to-one, blah, 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 okay? Whatever. This is all you really need to know for now, okay? The second thing to remember about inverse functions is that f of x's domain becomes, guys, g of x's range. Likewise, f of x's range becomes g of x's domain. Okay? So again, any sort of restrictions on them or things like that will flip around and whatnot. So keep that in mind, okay? But f of x's domain becomes g of x's range, and f of x's range becomes g of x's domain, okay? The next thing, okay, as a reminder about inverse functions, is how to find an inverse function if I'm given a function, okay? Basically, all you do is you switch the x and the y in the equations and resolve for y, okay? So, to find an inverse function, you find the inverse tool function. Okay. Swap x and y in the equation, then resolve for y. Okay, an example, say I have y equals 3x plus 2, okay? Its inverse is going to be x equals 3y plus 2, which we didn't fully resolve, okay? So it would be x minus 2 equals 3y, okay? And then x minus 2 over 3 equals to y, okay? Those are inverses. Okay? Everyone catch that? So all I literally did, okay, was switch the x and y. Just straight up switch them, okay? That's how you produce an inverse function, okay? This, as far as the calculus is concerned, this is all you need to know about the workings of inverse functions, okay? From a algebraic standpoint, okay? We're about to talk about the calculus of it here in a second. So everyone make sure you got this down, okay? Yeah?
What is the word resolve?
Resolve? Yeah, resolve. Okay? Figure back out what y is, okay?
Nah, we're doing 3 on 2, 2 and 1. versus Max is very low. Max is too good.
I'm trying to.
Alright,
X equals 3y plus 2, x minus 2 equals 3y. What? I don't get that. I
Okay.
wasn't playing.
we just push
What
what I do right here.
Why are you scaring me?
Okay,
You know what I mean?
now,
I thought I should.
how the derivative works for inverse functions. Derivative of inverse functions. Okay? Basically how they work is that if f of x and g of x are inverses, then the derivative of g prime of x, sorry, the derivative of g of x, so g prime of x, is equal to 1 over f prime of g of x. Okay? So the derivative of g of x is equal to 1 over the derivative of f of g of x. So f of x evaluated with g. Okay? Everyone see that? Okay? Is how this works. That's the formula for inverses. And of course, obviously, provided that f prime of g of x is not equal to 0. Because if it's equal to 0, does this work?
No.
Nope. Okay, it's undefined, it blows up. Okay? But let me give you an example of how this would actually work. Okay? Because it's actually not so bad. How you get a problem that involving this, okay, in calculus, would be you would be told something about f of x and g of x are inverses. So this is an example here, okay? f of x and g of x are inverses, okay? If f of x is going to be equal to, make it 3x squared plus 2x minus 1, okay? And then g of x is going to be equal to, we're going to say not g of x, but g of 2 is going to be equal to 3, okay? What's g prime of 2 equal to, okay? All right, so we've defined, so instead of giving you an equation for g of x, we just told you at 2, g of x is equal to 3, okay? But then we're asking, okay, what's the derivative of that then at the same point, okay? Now, I don't have g of x, so I can't just simply take the derivative of g of x and plug it in to solve. But what I do have is f of x and the fact that the two things are inverses. So I'm going to use this formula right here, okay? It's going to come along and say, well, g prime of x is going to be equal to 1 over f prime of g of x, okay? F prime, so it's going to be g prime of x is equal to, the derivative of f of x is 6x plus 2, right? This is going to be 6 times g of x plus 2. Okay, well, we want g prime of 2. That's going to be 1 over 6 times g of 2 plus 2. G of 2 is 3, so we can figure this out.
Bless you.
So,
God bless you.
the derivative of g of 2 is 120. Okay? According to the theorem. Okay?
Please say f prime g
G of which one? Where? G of 2.
Where you get that 6 from?
6 is from the derivative. Derivative of f of x was 6x plus 2, right?
Yep.
Maybe I should just write that up there. F prime of x is equal to 6x plus 2. So, all I did was just follow what it said. Okay? So it's literally just, the problem you get with this is literally just replacing things with numbers and using this little theorem here. Okay? They're ridiculously easy problems.
So G of 3.
G of 2 was given to us. It's 3.
Okay.
Okay?
Yeah.
That's what it says, basically. Okay? And then you're just, since we know what G of 2 is, we can just replace it, any use of it, with 3 and figure out our answer. Okay? So it's this is the relationship between the inverses when it comes to the derivative. Okay, everybody?
Yep.
All right. That hard?
No.
No. Okay.
Yeah.
Then this is as hard as it gets on the AP, by the way. They don't do anything else other than
That's
this.
as hard as it gets.
Yeah. They're not going to give you anything more difficult than this.
Can't
on
get
the
any
AP.
harder.
That's what she said.
Huh?
You're a child.
I got that on YouTube.
Yep.
On YouTube.
Forever immortalized online for saying that's what she said.
Bitter. Good joke.
All right. Any questions here?
Could you hold up one second?
All right.
All right.
All right. Excellent. Moving onward now. Okay. What we're going to look at the rest of the class today, okay, is a special group of inverse functions. Okay. The inverse functions we're going to look at are the inverse trig functions. Okay. So we're going to look at inverse trig functions. Okay? So, these are functions that undo trigonometry normally, correct? So, if I had, for example, okay, if I had the question, the sine of theta equals 1/2, how would I figure out what theta is equal to?
You take the arc sine of 1/2.
You do the arc sine, right?
He's a
Right.
genius.
Okay? You would say the arc sine of the sine of theta is equal to the arc sine of 1/2. So theta is equal to, hey guys, pay attention, arc sine of 1/2, and you either look that up on the unit circle or go to your calculator or anything like that. It's pi over 6, by the way. Okay.
What?
Yes.
What?
Okay, and so, that's what we do with, okay? So the arc function here, okay, the arc sine is the inverse to the sine, okay? Hey, that's the key, right? We like that, okay? So, if I'm doing stuff with the derivative of the arc sine, okay, I could go through and I can use that derivative formula I was given before, right, for inverses, use the sign with it, and be able to figure out the answer accordingly, correct? Well, while that would certainly work, the thing is you don't want to have to do that every single time you do an arc sine, okay, the derivative of the arc sine. Also, you don't want to have to do that every single time you have a function that's going to behave this way to try to figure out how it works. We want a better way of doing it, okay? And so that ends up being, there are rules for handling the arc sine, okay? Derivative-wise. And so we're going to take a look at those in a second. Got this copied down? Okay? Yeah? No. Okay.
It's unfortunate.
Although I should make it,
No, I
because,
did.
but I'll save arc sines to the next
Hey, you
round.
wanna end up like
Okay, Park was 4.
Right,
Oh, if you look at the unit circle, the reason for it, on my unit circle, this guy, okay? The sine of theta equaling 1/2 happens at this point when it's 1/2, sorry, root 3 over 2. 1/2, and that happens at pi over 6. Theta is equal to pi over 6. So to undo it, yes.
That was a 30
No, I don't put down the answer. Hey, everybody.
Hey.
No, I didn't put down the answer, the other side, the 5 pi over 6, because the arc sine actually only returns answers between negative pi over 2 and positive pi over 2. Okay? So if you remember unit circle, here's where pi over 2 is up here. 5 pi over 6 is over here. It's what? Beyond the unit circle, right? It's beyond pi over 2. So leave it off. Okay? So, what we're going to look at is how to do the trigonometric functions we're going to look at. Okay? We've got, there's 6 total.